everyone and welcome to my YouTube channel. Today, we're diving into an important concept in vector math, scalar multiplication. If you ever wondered how to make a vector longer, shorter, or even flip its direction, scalar multiplication is the key. In this lesson, we'll break it down step by step with simple examples and visuals to help you understand exactly how it works. Ready to get started? Let's go!
At the end of this video lesson, students will be able to explain what is a scalar multiplication and identify a scalar in mathematical expressions. Students will multiply a scalar by a vector and describe the effect on the vector's magnitude and direction. Students will apply scalar multiplication to a matrix and demonstrate how each element is affected. These students will solve problems involving scalar multiplication in physics, economics, or computer graphics. These students will recognize typical mistakes in scalar multiplication and explain how to avoid them. Scalar multiplication is a basic operation in mathematics where a single number called a scalar is used to multiply each element of a vector or a matrix. In the case of a matrix, every entry in the matrix is multiplied by the scalar, so multiplying a 2 by 2 matrix by 2 will double its values. This operation changes the size of the vector or matrix but keeps its direction or structure the same unless the scalar is negative, which reverses the direction. So now let's calculate 3a. 3a is equals to 3 times 4. We're going to distribute this scalar 3 into these elements of matrix A. So that's 3 times 0, 3 times 7, 3 times negative 2, 3 times 1, 3 times 5, 3 times 0, 3 times 2, and lastly that's 3 times 9. Okay. And now let's multiply each element by 3. 3a is equals to 3 times 4, that's 12. 3 times 0, that's 0. 3 times 7, that's 21. 3 times negative 2, if we're going to multiply positive and negative, the result will be negative. So 3 times negative 2, that's negative 6. 3 times 1, that's 3. 3 times 5, that's 15. 3 times 0, that's 0. 3 times 2, that will be 6. And lastly, we have 3 times 9, that is 27. Okay. And there we have it. 3a is simply each element of A scaled by 3. To recap, scalar multiplication means multiplying every element in matrix by the same number or scalar, and this is the foundation operation in linear algebra. Okay, for our example 2, we have two matrices. We have two matrices, matrix A and matrix B. Our matrix A, that's 2, negative 3, 1, and 4. Our matrix B, that's negative 1, 3, 5, and 0. So let's go into find negative 2a plus b. So as we can see, we have 2 by 2 matrices, 2 rows and 2 columns. And our scalar is -2. This is our scalar. So now let's compute -2a. -2a is equals to -2 times 2, -2 times -3, -2 times 1, and -2 times 4. Okay, now we're going to multiply each entry by -2. The result will be -2a is equals to -4. That's negative times negative. That will going to be positive. Positive 6. Negative times positive 1. That's positive negative 2. Okay. -2 times 4. That's -8. Now, let's add this. As we already get the -2 matrix A, we're going to add the matrix B. So, -2a plus b is equals to -4, 6, -2, and 8 plus -1, 5, 3, and 0. Okay. Now we're going to add this. -4 plus -1, that's -5. -6, positive 6 plus 5, that's 11. Okay, -2 plus 3, that's 1. And lastly, -8 plus 0, that is -8. So now, we already get the result of the -2a plus b.
And that wraps up our lesson on scalar multiplication. Now you know how multiplying vectors by scalars can stretch, shrink, or even reverse their direction. Don't forget to practice and apply these concepts to deepen your understanding. If you found this helpful, make sure to like, subscribe, and check out our next lesson on vector operations. Until next time, keep learning and keep practicing. Bye!